So I'm Stanislav, and I will be talking about graphical user interfaces. The reason I will be talking about them is because I have some experience with them, and I switched to the libraries during the time. So I will tell you my subjective experience about what worked for me, what didn't, what I didn't like, what I had to learn, and stuff like that. So what's graphical user interface? Basically, that's thing which we see in some window, and programming graphical user interfaces is a little bit different than your usual object-oriented programming because it's so-called event-based programming. So you basically do some setup, and then the thing runs on its own. And how is this done? First, you have some widgets. Does everybody know what's a widget? If you look at the window I have there. So for example, a widget is a button or the progress bar or anything we put there for the user to interact with. When we do this and create all the widgets, we then need another part of the program, which is called a layout manager. We can have one or more, nest them, and they are responsible for laying out the widgets on the window, and also to respond to events like resizing the window, maximizing the window, and they tell the widgets how they should stretch out, how they should basically lay them out on the window itself. If we do that, basically, our window with the application can respond to some events like resizing, moving it. But that's not all, right? We also want our widgets to respond our own events, like if you click the button, we want to run some code. So we write the code, put it in some either a function or method, it depends on the programming language we use, and bind it to the event. So we call these callbacks, and we bind them to the events of the widgets. And then, when we have this setup ready, we start event loop. It's basically infinite loop which runs. It processes the events and calls our callbacks. And that's, in the nutshell, how the graphical user interface behaves. Now, to do the programming, right, you need some library which will provide you the widgets and the event loop and everything you need. And there are quite a few of them. Some of them are directly in your operating system, like Windows API. It's directly in the Windows. Also, like Qt and GTK, we have desktop environments which use them directly. But also, what you can use some cross-platform libraries which will run everywhere. So for Python, there are some very common ones. Basically, none of them is written in Python, right? They are written in either C, C++, or TCL, which maybe you are not familiar with at all. And there's always a library for Python, which is basically a wrapper, which wraps the C code or C++ code or TCL. And why is this important? Because sometimes we don't have a good documentation for the library in Python. We can go back directly to the C++ implementation, look at the code, or look at the documentation for C++. And usually, because it's just a thin wrapper, we can do the transition easily. You know, if you know a bit of C++, you can read, for example, Qt5 documentation for an example, or find it somewhere, on some forum or something, and then translate it in your head to the Python equivalent and work it out. So the obvious question is, so we have many of them. Which one is the best? What do you think? Well, I had this sentence here. I wrote, they are all horrible, or they are all good. The thing is, it depends, right? I guess you saw this coming, right? It depends, and it depends on a lot of things. First, there are some advantages, so you have to weight them and then select. Also, there's this thing. It depends on the target platform, like what are you targeting? Now you will be maybe thinking like, wait a minute, didn't we talk about cross-platform toolkits? Yeah, one thing to know, they lie. Every cross-platform toolkit has one of the platforms as a first-class citizen, so like everything works perfect for that platform. And the other ones, well, sometimes there's a graphical glitch, sometimes you have to hack something, you know, unexpected things, it looks weird, you know, on the other platform. So, if you know like 90% of your customers or like users will use Windows, obviously you will select the library which looks perfect on Windows, and well, others will cope with the glitch here and there and be happy that they can use it. And there are other things which you may want to consider, and I will talk about them in other slides. So now I have this list of the four libraries, and I actually used them in the past, and they are listed in the order I learned them and I use them. And of course, the first is Kontár. Why? Everybody knows, right? Because it's in the standard library. So if you are like, well, I will need some buttons and input and a window, first thing you find is Kontár. It's very simple to learn the basics because it's very simple library. And also good thing about it is from all the ones I have listed, this one needs the least memory. Also, if you like bundle the stuff and the library itself and try to zip it, it's on the disk, it's the smallest one of all these. What disadvantages? Well, the first one, which you would maybe expect, not all the widgets you are used to are there. There are just the simple ones. It was improved by the extension, which is called TTK. There are some new ones, but for example, like this time spinner widget, where you have like hours, minutes, seconds, and and you can like use your keyboard to go up and down, and it loops and at midnight, doesn't exist there. You have to use something more simple or write it yourself. Sometimes on some platforms it doesn't look native. It doesn't behave native. The image I have there, it's from my GTK-based environment. That's not how my GTK environment looks like, and the applications written for it, how they look like. So on Windows, it was improved with the TTK extension. It looks quite good, but I was there was surprise for me on Linux that it doesn't work the same way everywhere. Also, because it's a TCL extension, and if you are not used to TCL, documentation will look weird, and also the way how you use the code, because it's a thin layer, the wrapper on it, it may be just weird. You have to learn it, and you can use it. So when I needed the more complex widgets, I noticed that there is this popular library, WXPython, and it has many advantages. First one, it always uses the underlying platform's widgets. So the look will be fine on the platform you will use. Also, they have this whole bunch of demos and examples where you can find like everything you will need. So it's very easy to learn. Also, the wrapper itself is not just the wrapper. Some developers created very nice widgets, which are extensions of the WXWidgets library, which is underneath. So you can do crazy stuff. They have like 3 views where you can put images and checkboxes and whatever you want. Disadvantages are, for me, most important, it doesn't run in Python 3 yet. or not the stable version of the library. Also, as I said, the look is okay on the platform, but I encountered a lot of problems, especially with the layout managers, and I had to write some code to improve on it and like hack the problems I found, the glitches I found, to work around them. It's not a big deal, you can do it, but it's, sometimes it takes your time. Also, at the time I was looking at the library, it seemed like one guy is developing it. Now it seems it improved based on the info they have on their site, but that's why it's still not in Python 3 ready. Not many people are working on that. So when I finally switched to Python 3, I needed a new library for my graphical user interfaces, so I tried PyQt5. Well, at that point it was 4. I moved to 5 when I could. And I was amazed because this library is very well documented, and it feels very mature. Like everything works. You are expecting it. It's very easy to use. Also, you can style it fine using HTML and CSS. It has its own resource system, so you can take like your images and sounds and pack them together into your application. It looks perfect on Windows. So if you are going to do graphical user interface for Windows, look no more, take this one. Also on Qt-based desktops, it of course will look fine. Disadvantages, maybe you know or not, the Qt itself is LGPL licensed, so you can use it in proprietary code without a lot of problems. But the PyQt itself is either a GPL license, so you have to go open source, or you have to buy a commercial license. There's another library which is also a Qt wrapper, which is called psite, and it basically died when Qt5 was a new thing. It seems that the Qt, whoever now owns Qt, I think it's called Qt company, right? They announced this psite 2 effort, which should be LGPL wrapper on Qt. It's not there yet, so we'll see. I had some problems with it on my GTK desktop, which seem to be fixed now. But you have to keep this in mind. You can encounter weird behavior. Also, the look and feel of the Qt application is a little bit different to the GTK one. But if you use any Qt application, you probably noticed. And so the question is, do you care? Okay, so next one and the last one for me. Of course, I wanted some native GTK applications. So I looked at Bhaiji Object, which is wrapper on GTK 3. Well, it's you can use it. Its main advantage for me is that it integrates well with GTK-based desktops, so you can do like notifications, for example, on GTK desktops. Also, the people who did the wrapper did a good job to extend the constructors, so you don't have to like create your widget and then set on every line some attributes. You can do it all on the constructor, which you can't do in C++, for example. So it's neat. Disadvantages, it's kind of new, so the documentation is not really good. Also, the GTK3 library is moving forward a lot, and they break things, they deprecate things. So like when I was trying to make my example work again, I spent an hour to finding out what they removed, So it's kind of fuzzy in this way. You may want to consider other things. There are some libraries you can integrate with the graphical user interfaces. Matplotlib is for creating charts and stuff. It's cool because you can use it in every one of these, so that's nice. OpenGL, if you want have an OpenGL view in your application. Then some of them have already included widget OpenGL. So you just put it there, write your OpenGL code, bind it for some events, and you are done. Some of them are not included. There are third-party options, which sometimes, I didn't try to use them, maybe hard. For example, for Tkinter, I found one. The development ended 2006. So maybe it works, maybe it doesn't, Resource systems, if you want to pack your resources like, images, icons, may be useful for you. Also, if you are planning to style your application, like change colors, do some views on links, and stuff like that, then maybe it will be better for you to select something which is easier to style, like Qt5, for example. Now, there's a thing which is like the most common problem people encounter when doing graphical user interfaces. You create your callbacks, and your callback runs for 10 seconds. What happens? Right. You block the even loop. Your graphical user interface freezes. You try to move it. It doesn't, or you hover. Your buttons don't highlight, or it goes gray, everything. You don't see anything. So what do? It's easy. You just create another thread for your work, and you're done. Your long-running task will run in another thread. Your main thread will still work with the graphical user interface. Perfect. And then you have this thought, maybe I would like people to see the progress, right? So you, update some progress bar from your second thread. And what happens? It crashes, right? Because the graphical user interface libraries are usually not thread safe. So when you try to update the graphical user interface from second thread, it sometimes works, sometimes it doesn't, sometimes it gives you core dump and you are done. So what you can do about this? You have to use some memory location or some structure which is thread safe. Do we know some? Usually, for example, in Python, we have queues, and they are thread safe. Perfect. Also, all these libraries have an even queue, which is a queue, so it's thread safe. So, for this reason, every one of these libraries has some mechanism how you can tell it from another thread. Well, when the even loops runs next time, run this thing for me in the main thread. And this is the thing, if you are learning the graphical user interfaces, which you should look into and learn first, because you will 100% sure you will need it. Now, I have some code show for you. So how does it look like? So this is GTK, this is Bhaiji Object. I've selected it because it's readable. So let me see. So you can see these parts I was talking about. So first you create some widgets. So this is a very simple example. It creates just a button. Then you need some layout manager. So I've selected the box layout manager. And then you tell it how it should pack the button inside it. I don't remember all the parameters, but I think it's like a stretch horizontally, vertically, and the last one I'm not sure. And then you tell it, well, add the box to the window. So the window will use the layout which you specified. Then you select your callback. So you say, like, when the application tries to quit, call this GTK main quit, which will break the infinite loop. And then you bind your button to, when you click it, call this callback function, which is just a print here. And then you show the graphical user interface. And if you look at the main, so we create a window and we run the main loop, and it runs forever until the GTK main quit is called from the callback when somebody tries to close the window. And that's like basically how you write every graphical user interface. Okay, last thing I have for you. This is basically the same application written in all the toolkits. It's very simple. We can start it and stop it. If you look to my GitHub repository, the example is there, and this is the exact example of second thread running some, some work and showing it using the progress bar. But what I wanted to show you here, so this is the same application written in four of them, and now you can see the Bhaiji Object one is how it should look like. That's my desktop environment. How it's done. How progress bar should look like. Everything is perfect. And if you also you can notice that if I change to another window, what GTK does, it disables the buttons. It's GTK stuff, like how GTK theming works. And you can see I have the WXWidgets here application. It behaves the same. It looks a little bit different, but it uses the same widgets. Now the Qt5 looks differently. Because it draws its own widgets by itself, but it tries to use my theme of the GTK, so it kind of looks similar. It's not perfect, but I can tolerate this. The Tkinter, you can see it's different. That's the price we have to pay for using it. And that is all from me. If you want to look up the examples, you can go to my GitHub repo. It's there. You can look at all of them. Just warning, the WX Python one I didn't finish because I didn't want to code with Python 2 anymore. So it only draws, but it doesn't do the thing. But if you would like to use it, I have put down there some pointers how to do it in WX Python. If there are any questions, I can answer them. Okay, Kiwi. I tried to use it, and I guess I was so lazy to set it up. It's not like you install the library, import it, and run it. All of the others do it this way. Kiwi, I had trouble to wrap my head around how it should work, and yeah, I gave up. About the HTML and local web server, I think people are going that way a lot these days because it seems to be easier. Yeah. Why all the toolkits suck so much? Yeah, I think it's so much work to make it really cross-platform and working perfectly on all the platforms that nobody wants to code with it, and without some corporate backing, some real money, it's not gonna happen, I think. And I have to confess, I tried even the Windows stuff, Visual Studio stuff. They have these WinForms, which are now deprecated. They have something new. It sucks too. It has the same problems all around and all the time. So, now comparing by quality of available dev tools, PyQt all the way. They have the best tools. They have the UI designer, which is actually useful. I don't like them because I think it's very easy to learn it, to code it yourself in a text file, and it has so many advantages. You can go to Stack Overflow and show them your code. They will help you. You can generate the widgets based on whatever you read in the database, like add checkboxes for every row or something. It's much easier to draw it in this UI designer and then trying to make it work as you want. So I would say it's better to take the time and learn how the framework works and do it by hand. But that's just me, maybe. Yeah, I'm not sure we have any more questions. I can't read them.
Yeah, if you have any more questions. We have a lot of time before the coffee break, so.
I wouldn't rush so much.
Thank you. Is it possible to use async I/O with these tools?
I don't think so. I don't know. What I think is the main premise of the async I/O that you have to have libraries which are written for it, right? And so none of these is written for it. So maybe you can use it for some. Maybe one good thing to do when you do graphical user interfaces to decouple the graphical user interface from your application logic. So your application logic can be happy with async I/O, but you shouldn't mix it with the graphical user interface, I guess. There's no real gain because every graphical user interface library is basically async I/O kind of, right? Because it has the event loop, it waits for the events, and most of the time it doesn't do anything. It just waits, because we people are very slow with our clicks, and typing the keyboard.
Yes, so when it does nothing, so why should we create another thread for the stuff if the application
most of the
does
time,
nothing?
Yeah, most of the time it does nothing. But if you, like if I go here, okay, let me see. If I go like here and hover here, do you see it? It changes color a little bit. If the long-running task is there and is blocking it, it won't react at all. If at the time when the callback is running, I take it and like move it this way, it probably won't redraw. It will be blank. So that's why we create another thread for the long-running tasks.
Okay. Yeah.
Yeah. Thanks. From what I understand, the question was more about the. You pretty much almost always want to do some more work in the callback. It's not like it's this very rare thing that you want to spawn another thread. At least that's what I found. So. Is there a technical reason why, for example, the GUI functions are not implicitly already in another thread context? Like, can't those callbacks that are exposed to your application be already in a new thread?
Well, I don't know why is that, but it's like usual way how they do it. I never thought about it this way. And I think maybe the main reason is because, like, all my applications, if I count the callbacks I have there, it's like tens of them, But most of them are fast enough so you don't notice and you don't care. If they are like under 1/2 of a second or under a second, you don't care creating new thread. So maybe I don't know. Like it seems nobody did it yet. To create the thread for every callback. Not sure why.
Okay, thanks.
There's one more question if we have time.
Last one, yeah?
Okay, so I have the answer to that question, which is that if you have a callback, if every callback runs in its own thread, and one callback is modifying some of the widgets on the screen, and then another callback starts running that's also modifying some of the widgets on the screen. So you can end up having, so if you had like one thread per callback, then you would end up with big problems. What you could do is you could end up with one thread that ran the GUI code and one thread that ran all the callbacks using a queue to synchronize between them. And that would work well, and it can be done, but I don't think that there is a toolkit that does it. But for example, when I was programming Haskell, I configured Haskell's GTK code to do that. So it's certainly possible, and it is probably the better way to do things. But still, if you think about when you start writing custom widgets, then you end up with this question: is your custom widget running in like backend code, or is it running in the GUI thread? Especially if your custom widget is, for example, a stock ticker widget that is actually interacting with data at the same time as it's drawing, then you get this conflict, and you actually have to really think about these things. So I think that there is a good reason why the threading is not explicitly built into the toolkits, because especially with the custom widgets where you'd have data, for example, Google Maps or stock ticker widget, where the data and the drawing code are very tightly mapped together, then you do want to.
But I think you are right. The main thing, which I'm not sure why I forget, is that you need the main thread to update the widgets. So you can, so the callbacks need to update the widgets, right? Okay. Thank you.